All right, craft complex mock data. Thank you everyone for being here today. I'd like to talk about making up data. Now, not making up the malicious kind of data, but the fun, productive, deeply interconnected and intertwined data, right? Data that is structurally so good that you'll be left wondering, did my data engineering team just give me a dump of production data? All right, so why? Why does really complex data matter, especially complex fake data, right? So we all know that real world data is very messy. You've got lots of different systems that are siloed, talking to each other, but the aggregate of all that data is what makes your applications sing, right? That's what makes them valuable, right? So having complex mock data that you can test against or to prototype against is hugely useful, right? So if you have just simple mock data, you can do unit tests. But if you want to do integration tests, really good integration tests, you're going to need really complex data, right? So that's one of my many reasons why you really need complex data. Okay, so when you are creating complex data, there are a couple options currently available. One is to get actual production data. That is a little dicey, right? Because there are a lot of PII concerns that is probably going to be in any interesting real world data, right? So you gotta be cognizant of this, right? So very likely you may not even get production data, right? Now there are some options like Tonic and Gretel have the ability to create synthetic data from your production data, right? So you get real data and they use ML magic and they give you a fake data set that statistically matches your actual data. But all the names have been changed, locations, et cetera, et cetera. This is great, but you still have a problem, maybe an additional problem. You have to now get your production data and have everyone else be okay with handing it to Tonic or Gretel to do this, right? Good luck. All right, another option is to find some other real world data that is very close to your data, right? Chances of you finding an exact data match is probably pretty low, right? Just because of the nature of what you're working on, it's probably unique. Or you're working on something that's incredibly generic, then you can find it on, say, Kaggle or some other data store. But very likely, even through that, you will still have to modify the data somewhat. Okay, another option is to use one of many, many mock data generator services and libraries, right? So here you can create lots of great tabular data. Right? You can just set up like, I want to create a person's table, names, addresses, blah, 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 blah. These services can generate that data very quickly and I think of very high quality. Downside is it won't do complex data, right? So you can get a table of people, table of addresses, table of widgets, but none of it's going to interconnect, right? It'll be, again, good for unit testing, not so good for integration testing. Okay, so that leaves custom scripts. This gives you the most powerful option. This can exactly match whatever your data structure is. However complicated your real world data, you can make a script that matches that data schema, right? Two downsides of doing this. A, you get to maintain the code for creating that mock data, right? So when your real world data changes, guess what? You get to go back and update that code, right? Last thing is custom scripts can be error prone, right? Because it's basically you're building another sort of sub-product to do. So, don't use your error-prone script. You can use my error-prone script. So what I've been so what I've been doing for the last year, on and off, is working on this complex mock graph data generator thing. And this is the shortest name I could get it to now, which is graph data generator, which will become apparent in a moment. But anyway, so this is on PyPi. I just pushed an update yesterday that I wouldn't recommend using, but it's up there. So after the conference, I will be updating this. So later I'll be asking you to see if you spot the error generation problem that I noticed last night. Anyways, so this is on PyPi. And how this package works is basically you give it a JSON configuration of the data structure you want, right? I'll come back to this. You feed it into the package, and the package immediately takes that, creates a bunch of mock data into a series of CSVs, and then packages it into a zip file. It also has an accompanying JSON file, which I'll come back to later. But those CSVs that it creates could be imported into any other database, right? It's basically got all your tables of people, locations, starships, droids, whatever, and a bunch of CSVs that basically look like lookup tables that join all the different pieces together. Okay. All right, so high level, that's how this package works. Okay, going to the JSON file. To make it work, it's looking for just a very simple JSON dictionary that includes just two keys, nodes and relationships. If you're familiar with graphs, you'll know that nodes are basically vertices. In our case, for data, it's just a category of data type. And then relationships is the thing that joins data. That's the interesting bit, right? Does this person live on this planet? Does this person know how to pilot a X-Wing? That sort of, that relationship is notated here, right? That way, you can define the complexity of your data in a graphical way. Graph being network graphs, not a visual graph, right? Okay, so why do it this way? Because this is kind of how we naturally do this, right? When you're sitting around with friends or a partner and you're like, okay, I got an idea for this awesome application and it's gonna work like this in the back end. You're gonna get a napkin drawing that looks something like this, right? Things tied to other things with lines connected to other lines. Most of the time those lines aren't labeled, but you could for extra clarity, right? Okay, so anyways, this is why this is a good way to model complex data. Because honestly, I don't know how else you would model, right, the deep interconnections between different data types. If somebody does have a better idea, let me know. Okay, so as you can imagine, that JSON file, for every node and relationship you're adding in basically a JSON entry, if you're doing anything remotely complex, you know that this JSON file is going to get really dense really quick, right? So nobody wants to do that. You could, you know, if you're really good at, ooh, sorry about that. Let me not move this. But fortunately, there's a lot of tools that allow you to model things as a graph, right? Miro, which I'm using now, is a good example. Lucid Chart, you could do it in slides, keynotes, etc. But I'd like to point out a certain app that's free and very little known called arrows.app. I'll try to show this later if I have time. So basically, same thing. You're dropping a bunch of nodes, and you're drawing up relationships between those nodes. And this is basically a digital version of that napkin drawing that you were doing earlier. Okay, and the great thing about this, which I didn't show, is if you click on that download export button, it gives you a bunch of options. Most of them are for exporting this visual representation, right? Like basically a GIF, a SVGN, graphic options. But one of them is a JSON file. That JSON file is compatible with, oh, that's not helping. That JSON file is compatible with my packages file. It was actually the other way around, right? Like I built it off of that spec. Okay, so let me go back here. If I take just this and the JSON file from it, it will produce basically all these CSV files, right? So you got the persons, in this case I had two, right? Because I was defining speakers and attendees. Right, so I've got two different person files, and then all the intermediary lookups. So you can see here, this is probably not so useful. It's just a bunch of unique identifiers differentiating the different speakers that I wanted. Okay, so not so useful, but it's a start. Now, if I go in and I add in a bunch of properties to these nodes and relationships, my package will look for those keywords, and it will start generating constraints around the data it generates. So before, it was just like, okay, you didn't tell me what this person is called, so I'm just going to give it a UID and call it a day. Here I just put the count, so I want 3 of these speakers. But I could also put in first name, last name, social security number, whatever, and then define what mock generator I want to use. And when it goes and creates each of these person nodes, it will go and create mock data that fills in that property. And then you get a much richer data set. Okay, so I have a little bit of time here. So I'm just going to show this real briefly. If I can find. Oh. Okay, so here I'm just restarting poetry so I can find which window this is part of. Oh, right. So I'm jumping ahead a little bit here, but here you can see that I've got the same arrows generator here. And here, we'll just give it a name, string, and count. I'll just make 10 speakers. I'll do 3 speakers and maybe we'll just do 20 attendees. Okay, so that's all I'm adding to this, right? So I'm just going to export this and run it, and so you can see the difference without filling out the entire graph. All right, so the data it spit out is this zip file. And in here, if I go to person, there should be, what would I say, 3 of these and then 10 of the others. So here you can see where name was given an actual value this time, right? So let me go back. So all I did here was in the person, I just notated that I want a string for a name. So a string, so any of the sort of scalar values are also coded up as a shorthand. So if I put in string, it'll generate a random lorem ipsum string, datetime, integer, float, etc. But this gets much better once you start using kind of the built-in functions, right? So if I wanted something for city, I want actual city names, right? In here, I can give it a name property. And what I'm putting here is I'm putting a stringified JSON kind of object that tells the script, okay, use the city mock data generator and just pick a bunch of random city names every time you generate a new city for each count, right? So as you can see, I'm not going to do this now, but basically, if I go and I notate every relationship or every node, or the ones that I'm interested in, it will start constraining the randomness of the data, right? Under the hood, there are a bunch of random data generators that I'm using to leverage and generate those data points. If you're familiar with Faker, that's the one that's my kind of primary go-to. That's used most heavily in this package. So if you're familiar with that, that is kind of pre-built into this. Okay, let me go back to my slide here. Okay. Okay, so what I kind of skipped ahead. So what I just showed you is actually a Streamlit app that I've built around both the package and the Arrows app, right? So Arrows is just this public free app. I just embedded it in an iframe. And what I did was I added all the generator designations into a scrolling panel so that you could easily search for like, hey, I want to generate, you know, a first name generator or a last name generator. Let me go back to that actually. Right, so you can see I put in a bunch of pre-built things, right, for generating all sorts of stuff. This one I like, string from CSV. So if you have a CSV file, like say you use ChatGPT to generate a whole list of imaginary theme park rides, you could put that somewhere that's publicly accessible, point this to that, and the app will randomly select from that list that you've generated from other services. Okay. All right, demo that. Okay, so one thing I didn't show was actually how this package works. So when the JSON configuration comes in, all the nodes and relationship data is turned into this sort of intermediary nodes mapping object and relationship object mapping thing, right? It's just kind of a generic container so that if I want to change how I want to generate data, I can do that easily. And what happens is it generates all the nodes first, right? Because those are the things that need to connect relationships. So it really makes no sense to build the relationships first. So all the nodes are generated, and then all the relationships are connected. While it's generating, it's going through and looking at that value notation that I talked about, whether it's a string keyword or stringified JSON object, then it will basically do all this forking magic. Oh, I'm going to use this generator. I'm going to pull it out and run it. And if I show you the code you will both reel and horror, and then maybe be inspired to help me make it better. All right, so here is the package. Okay, so here, basic init file. So this is just the key function that it gets, right, which is the generate function. You pass it in that JSON source data. I'm not really using the output format anymore. And you can enable logging, which I've just kind of added. So really, the key thing is just the JSON file. And then what it will do is if your logging is enabled, it'll enable a module logger. So the module logger allows the underlying package logs to kind of surface to this Streamlit, to a Streamlit app, or to any app you're running. OK, so I'm just doing a light check on the JSON source. This is actually a terrible check, but it's better than nothing. Then I generate those mapping files that I was talking about. And then the really cool part is the generate zip part. This part is gruesome because I have commingled the CSV generation and the zip generation. But anyways, this will go through and kick off that generation process that I talked about. All right, now that I finally looked at my colleagues in the back and realized I'm only 1 minute left, we got time for probably one super fast question before we got, yes? 5 minutes after this. OK, all right. No, it's OK. Oh, all right, so I'll just put it on my last slide because I was really just one away. So if you want to look at the code, this is a link of links. It has the links to my code repo and also the PyPi package, my LinkedIn info, and some info on Neo4j if you want to take this further and dive into that data in a graph database. So yes, question?
Thank you. It's an interesting result, and I like the tools for generating the initial configuration. The thing that worries me the most is updating that configuration over time, especially if the changes are obscure or I don't control the source or something like that. Is there anything you found to be useful to help with that?
So you're talking about drawing everything up in the Arrows app, right?
Yes, and then I have a configuration, and then someone else makes a very obscure change that I need to see reflected. Is there anything you found useful for making ongoing changes to this thing easier or more productive?
I would just update the Arrows app, right, which is easy enough to add in a node. And so I'm waiting to make sure everyone's done with this. So let me show you in here. So if you wanted to modify this, right, so say we want to break up locations. Right? So I can add in. Get this guy. So we could do things, like state is inside a country. And so you can see here, like, expanding the model is very easy in Arrows. And then right now I have it just set up where you would do this download, export, right? Grab this JSON file, put it into another runner and do it again. Ideally, it'd all be just connected. I go, like, every time this is updated, just update the backend database, right? Yes, that is where my future self would like to be. So, yes, question?
Similarly, this was really cool, by the way. Thank you. The Arrows app was super cool in that I've never seen a tool where it makes the modeling so easy for some of these graph structures. But I'm curious if you could suggest any resources or like a smattering of best practices on how to better model graph data.
Model graph data? OK. So that's a great question, and it's very domain specific on creating the best data, right? Especially with the way this is set up is meant, to readily combine with Neo4j, which is a property graph database. That means both the nodes can have properties, and the relationships can have properties, right? Like distance, whatever, or you can give the relationships weight or other information, right? So how you structure it can radically change how efficient your graph queries are, right? So using Cypher, which is our query language. The decision between making it a label, like this, or making the whole address like a property of a node is a good question. In general, if the data you're interested in pulling into your application is dependent on, it's very dependent on location, then that should probably be a node like this. Should be its own label, right? Because when you put anything as a property and you search for it, you have to pull all those data points and then filter through the property to find it. But if it is a node label, you don't have to do that. It just looks for that type and grabs all those data points from that type. So node labeling is generally more efficient. But you have to be careful, because if you tie too much information to one node, you get a super node problem. And then in which case, well, that's not really useful at all, right? Like everything is connected to air. Great, is that useful for your app? Maybe, maybe not, right? So yeah, but yeah, this tool is so easy. You can quickly try out variations until you have like a data model that you're really happy with, right? So, yes, any more questions? No? Good, well, I'll still be here, and my colleague Yolande will also be here. We'll answer questions. Oh yes, we have an online conference coming up at the end of the month, so if you really want to learn about graph stuff and how to get a handle on it, definitely join us. It's on October 26th. Yes, awesome. Cool, all right, thank you very much.